Hi everyone, today we're going to talk about Group 1 alkali metals.
Whether you've left school or you're still at school, you can appreciate the sheer fun and mayhem that chemistry can be. There's so much to it. Bunsen burners, mixing chemicals. Very nice. Now, you may have been allowed to mix very small amounts of lithium with water. You may, if with a responsible adult, have mixed H2O with sodium. And you may, under very strict scientific control, have witnessed potassium mixed with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, mate, present.
Oh, thank you very much.
These next two are the dog's nuts of the periodic table. They are, if you like, the king and queen of alkali metals. Mix these babies with water, stand well back, and watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
Okay.
Good luck. Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody. This one's going to be bad.
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone. Yes!
Wow.
That is more like it. Only on Brainiac do you get that kind of science. But I believe we can go one better. There is one more alkali metal we can legally use.
Yes, Richard, cesium, the emperor of alkali metals, particularly nasty, could go off at any time.
And that's it.
Oh, yes.
Brilliant. I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave you to it. Good luck.
Thank you.
Okay, John. Go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does. Magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, francium. But for some reason they wouldn't let us have any of that. Still, there you go. Today's lesson.
Never mixed alkali metals with water.
Now, today's learning objective is: describe the property of Group 1 alkali metals, describe the trend of the property of Group 1 alkali metals, and explain their reactivity according to their electron arrangement. And also, we need to be able to write chemical equation when alkali metals react with water. Now, the first question is, what are Group 1 alkali metals? Now, we can see that there are plenty of elements being arranged in Group 1. One of them is non-metal, which is a hydrogen, and the rest are all metals. So now, today's focus is on all the metals in Group 1, which is lithium, sodium, potassium, rubidium, cesium, and francium. 2 things we're going to talk about today. First one is their physical property. The second one is their chemical property. Now, the physical properties are the things that can be observed or measured without changing what they are. Now, one example, if I want to measure how fat this cat is, I don't need to change the cat, right? So that means that I'm measuring the physical properties. It means that the fatness of this cat or the width of this cat is the physical property. So the physical properties that has been shown by alkali metals are, the first thing being, they are really good conductor of heat and electricity, which Basically because they're all metals. So that's why we use metals for pots and heating up things. And the second property that has been exerted by alkali metals is that they're really, really soft, which is quite different compared to the other metals. So lithium are so soft that you can even cut it with a knife. And the third thing is that they have really low melting and boiling point. Now, just like in a family, you will all have things looking differently. The alkali metals looks quite different from each other as well. The first one is they are all very soft, but their softness will increase down. So if you can see a pattern across down the table or across a period, if you can see a pattern, that is called a trend. So the trend or the pattern of the softness of the alkali metal is when you go down the group, the softness increases. It becomes softer and softer. Same thing with density. The general trend of their density is when you go down the group, the density will increase. Same thing with their melting point. When you go down the group, their melting point will decrease, which means that when you go down the group, they will melt at a lower and a lower temperature. And CCM will only melt at a temperature of 29 degrees Celsius, which is quite remarkable. Second part we're going to talk about is their chemical properties. Now, opposite to physical properties, chemical properties are the things that when you measure or observe what they are, you have to change them. For one example, the alkali metals, they are all quite reactive with water. Now, if we want to measure or observe these chemical properties, you have to change what they are, right? Because having them react with water, you would have to perform a chemical reaction, meaning that new things has been formed and old things has been changed. So when they react with water, the alkali metals will react vigorously with water. They will form hydrogen gas and leaving a solution called their hydroxides, which is another word for alkali. And the chemical equation of this reaction looks like this. So if you place sodium with water, you will form sodium hydroxide, which is an alkali, and hydrogen gas. And the same thing with lithium. If you were to put lithium with water, you will form two things, which is lithium hydroxide and hydrogen. Now, can you think of what is a reaction, what is a chemical equation when you put potassium in water? Your next job is to find this video on YouTube and to watch it, which is going to help you to look at group 1 metals into more details and what they look like when you have them to react with water. Once you finished watching the video, you can go back to our learning objectives to see if you're able to do all these 4 things. Thank you very much and see you folks next time.